Kepler-186f is an exoplanet orbiting the red dwarf Kepler-186, about 500 light-years from the Earth. It is the first planet with a radius similar to Earth's to be discovered in the habitable zone of another star. NASA's Kepler spacecraft detected it using the transit method, along with 4 additional planets orbiting much closer to the star. Analysis of 3 years of data was required to find its signal. The results were presented initially at a conference on March 19, 2014, and some details were reported in the media at the time. The full public announcement was on April 17, 2014, followed by publication in Science. Orbital parameters relative to habitable zone. Kepler-186f orbits a star with about 4% of the Sun's luminosity, with an orbital period of 129.9 days and an orbital radius of about 0.36 or 0.40 times that of Earth's. The habitable zone for this system is estimated conservatively to extend over distances receiving from 88% to 25% of Earth's illumination. Kepler-186f receives about 32%, placing it within the conservative zone but near the outer edge, similar to the position of Mars in our solar system. Mass, density and composition. The only physical property directly derivable from the observations is the ratio of the radius of the planet to that of the central star, which follows from the amount of occultation of stellar light during a transit. This ratio was measured to be 0.021. This yields a planetary radius of 1.11 plus or minus 0.14 times that of Earth, taking into account uncertainty in the star's diameter and the degree of occultation. Thus, the planet is about 11% larger in radius than Earth, giving a volume about 1.37 times that of Earth. There is a very wide range of possible masses that can be calculated by combining the radius with densities derived from the possible types of matter that planets can be made from. It could be a rocky terrestrial planet or a lower-density ocean planet with a thick atmosphere. However, a massive hydrogen-helium atmosphere is thought to be unlikely in a planet with a radius below 1.5 rash. Planets with a radius of more than 1.5 times that of Earth tend to accumulate the thick atmospheres that would make them less likely to be habitable. Red dwarfs emit a much stronger extreme ultraviolet flux when young than later in life. The planet's primordial atmosphere would have been subjected to elevated photoevaporation during that period, which would probably have largely removed any He-rich envelope through hydrodynamic mass loss. Mass estimates range from 0.32 mash for a pure water ice composition to 3.77 mash if made up entirely of iron. For a body with radius 1.11 rash, a composition similar to Earth, a unregistered trademark S yields a mass of 1.44 mash, taking into account the higher density due to the higher average pressure compared to Earth. Kepler-186f has an Earth similarity index of 0.64. Formation, tidal evolution and habitability. The star hosts 4 other planets discovered so far, though Kepler-186b, C, D, and E are too close to the star, and are therefore too hot to have liquid water. The 4 innermost planets are probably tidally locked, but Kepler-186f is farther out, where the star's tidal effects are much weaker, so there may not have been enough time for its spin to slow down that much. Because of the very slow evolution of red dwarfs, the age of the Kepler-186 system is poorly constrained, although it is likely to be greater than a few billion years. There is a roughly 50-50 chance it is tidally locked. Since it is closer to its star than Earth is to the Sun, it will probably rotate much more slowly than Earth. Its day could be weeks or months long. Kepler-186f's axial tilt is likely very small, in which case it wouldn't have tilt-induced seasons as Earth and Mars do. Its orbit is probably close to circular, so it will also lack eccentricity-induced seasonal changes like those of Mars. However, the axial tilt could be larger if another undetected non-transiting planet orbits between it and Kepler-186e. Planetary formation simulations have shown that the presence of at least one additional planet in this region is likely. If such a planet exists, it cannot be much more massive than Earth, as it would then cause orbital instabilities. Kepler-186f's location within the habitable zone does not ensure it is habitable. This is also dependent on its atmospheric characteristics, which are unknown. Kepler-186f is too distant, however, for its atmosphere to be analyzed by existing telescopes or next-generation instruments such as the James Webb Space Telescope. A simple climate model, in which the planet's inventory of volatiles is restricted to nitrogen, carbon dioxide and water and clouds are not accounted for, suggests that the planet's surface temperature would be above 273 kelvins if at least 0.5 to 5 bars of CO2 is present in its atmosphere, for assumed N2 partial pressures ranging from 10 bar to 0, respectively. Follow-up studies, target of SETI investigation. As part of the SETI Institute's search for extraterrestrial intelligence, the Allen Telescope Array had listened for radio emissions from the Kepler-186 system for about a month as of April 17, 2014. No signals attributable to extraterrestrial technology were found in that interval. However, to be detectable, such transmissions, if radiated in all directions equally and thus not preferentially towards the Earth, would need to be at least 10 times as strong as those from Arecibo Observatory. Another search, undertaken at the crowdsourcing project CITILIV, reports inconclusive but optimistic-looking signs in the radio noise from the Allen Array observations. The more well-known CT@Home search does not cover any object in the Kepler field of view. Another follow-up survey using the Green Bank telescope has not reviewed Kepler-186f. Given the interstellar distance of 492 light-years, the signals would have left the planet that many years ago. Future technology, at nearly 500 light-years distant, Kepler-186f is too remote and its star too faint for current telescopes or the next generation of planned telescopes to determine its mass or whether it has an atmosphere. However, the discovery of Kepler-186f demonstrates conclusively that there are other Earth-sized planets in habitable zones. The Kepler spacecraft focused on a single small region of the sky, but next-generation planet-hunting space telescopes, such as TESS and CHEOPS, will examine nearby stars throughout the sky. Nearby stars with planets can then be studied by the upcoming James Webb Space Telescope and future large ground-based telescopes to analyze atmospheres, determine masses and infer compositions. Additionally, the square-kilometer array would significantly improve radio observations over the Arecibo Observatory and Green Bank telescope. Comparison with previously discovered low-mass planets in the habitable zone. The nearest to Earth-sized planet in a habitable zone previously known was Kepler-62f with 1.4 Earth radii. Such a planet may be very different from Earth, as the volume of a planet grows with the cube of the radius and, assuming the same composition, the mass grows even more. Kepler-62f may be massive enough to have a dense He atmosphere and thus be a gas dwarf instead of a terrestrial planet. Kepler-186f orbits an M-dwarf star, while Kepler-62f orbits a Sun-like star. A study of atmospheric evolution in Earth-sized planets in habitable zones of G-stars suggested that 0.8 to 1.15 Rash is the size range for planets small enough to lose their initial accreted hydrogen envelope but large enough to retain an outgassed secondary atmosphere such as Earth's. Previous names, as the Kepler telescope observational campaign proceeded, an initially identified system was entered in the Kepler input catalog, and then progressed as a candidate host of planets to a Kepler object of interest. Thus, Kepler-186 started as KIC 8,120,608 and then was identified as KOI 571. Kepler-186f was mentioned when known as KOI 571-05 or KOI 571.05 or using similar nomenclatures in 2013 in various discussions and publications before its full confirmation. See also, Habitability of red dwarf systems, notes. References. External links, NASA Euro-Kepler discoveries Summary table. NASA Euro-Kepler mission. NASA NASA Press Kit, SETI Institute Google Plus Hangout Kepler-186f a planet in the habitable zone April 17, 2014, Kepler-186f at the NASA Exoplanet Archive, Kepler-186f at the Extrasolar Planets Encyclopedia.